So this event is organised by the network H2, and it's part of a series of webinars that are looking at different aspects of hydrogen research in the transportation sector. This week, we are looking at the challenges around multimodal transport and logistics, and are delighted to welcome two speakers from Ballard Power Systems Europe this afternoon, who will provide their own insights into this topic from a leading industrial perspective. We have asked each of our speakers to present for around 20 minutes, and once they have finished, we'll open up the mic and we'll have a Q&A session. Please, can you keep yourself muted until our speakers have finished? And you can use the chat function to enter any questions for the speakers as we go along. Jackie will has kindly agreed to moderate the chat, and will let me know when something's appeared. So this session will be recorded and uploaded onto the Net Zero website and also the Durham Energy Institute YouTube channel within the next week. And links will be posted in the chat shortly. First speaker is David Yorke. He's a marketing development manager at Ballard Power Systems Europe. And he will present on the operational and maintenance challenges of hydrogen freight and bus transportation. David's worked on zero and low emission buses for the last 12 years and oversaw all aspects of the London hydrogen fuel cell bus project, including the manufacture of the buses, set up of the facilities, and the daily operation of the buses. In close collaboration with Transport for London, Fuel Cells and Hydrogen Joint Undertaking, the Clean Hydrogen in Europe Cities, and environmental friendly, efficient electric motion projects, plus other stakeholders in that venture. David is a European and chartered engineer and has a master's degree in both hydrogen safety, engineering, and electronics. So over to you, David.
Thank you very much. So it's good to speak to you today. So my name's David Yorke. I'll be speaking to you first, talking about hydrogen buses, fuel cells generally, hydrogen trucks, and a little bit on the safety and maintenance of hydrogen vehicles, which is often something that isn't always spoken about too often. Then I'll be followed by Christina, who will go on to speak about marine applications for hydrogen fuel cell. And then we should get some time for some questions. So just by a way of introduction, hydrogen is very much on the map at the moment. It's being spoken about all the time by government, both here in the UK and European, and indeed worldwide. Possibly for this audience, these things are understood, but there's some big advantages of hydrogen when we're talking about decarbonisation. As hydrogen is a very flexible fuel, it's very good for transport applications, and it will be very important for industrial and critical infrastructure applications in the future as we move towards our zero emission targets. Heavy duty transport is where hydrogen fuel cell has an extremely good fit, especially today. And so when we're talking about heavy duty transport, we're going to focus on buses and coaches, trains, trucks, marine, these sort of areas, extremely advantageous for using hydrogen fuel cells, as opposed to the other alternative, which is battery electric. So there are a number of advantages of fuel cells over battery electric vehicles, and this will come up during my presentation a couple of times, so I won't dwell too long. But you've got good all-weather performance, you've got good range and payload, and a fast refueling time, which for a number of applications with heavy duty transport is extremely important. Fuel cell vehicles are becoming more adaptable, and it's something that is going to be very important going forward. As fleets expand, hydrogen is a very scalable product, and so we can expand to larger fleets often a lot easier than it is with battery electric vehicles. Certainly with buses and other battery electric applications, getting the power to the depot can be an extremely big issue and is not often spoken about. So just a little bit about Ballard. Ballard has been around 42 years, so it's not a new company. We've got a lot of experience in hydrogen fuel cell, especially in the heavy duty, have powered over 1,000 transit buses. We've got millions of miles in service. We've run fuel cells for over 35,000 hours, but we've also got some experience in shipping and trains. Moving on to battery electric buses. There's really only two types of zero emission battery electric vehicle. That's where you've got a battery architecture or a fuel cell. But the main thing to remember is that a fuel cell bus is a battery electric bus. And the fuel cell, the configuration, the architecture of the bus is almost the same as a battery electric bus. But the difference is that we're getting our electricity from a different source. So on a battery electric bus, we're plugging into the wall. On a fuel cell bus, we're creating the electricity on board and carrying our hydrogen around as a fuel in tanks. The actual drive line of the vehicles is exactly the same. The fuel cell bus has, as I said, a similar architecture to a battery electric bus, but the layout, as shown in the diagram, is quite similar. We normally have our fuel tanks on a single deck. We have our fuel tanks on the roof. Our fuel cell can be in the engine compartment where the diesel engine would normally be. You've got some form of hybrid components, and then you've got some sort of storage for your hybrid system. So, as I say, the actual configuration would be different, but if we had a battery electric bus, we would just have more batteries on board, obviously not the hydrogen tanks, but you'd still have the hybrid configuration. Also on this slide, there's a sort of brief diagram of how the fuel cell works, but very basically, we're taking hydrogen from our tanks, we're taking oxygen from the air, and then through a chemical process, we're producing the electricity that we drive the bus with, and our only emission is water, H2O. So, as was mentioned at the beginning, what are the advantages of a hydrogen fuel cell bus? Well, compared to a battery electric vehicle, we've got less weight. Now, weight is very important on a bus because if the bus is too heavy, we have to start losing passengers. But we can never lose sight of what a bus is there for. A bus is there to move people from A to B, and that's what we're always aiming to do. We have a good range on fuel cell buses. Can be over 500 miles range, which for a city bus is plenty to run the full day's service. You've got a rapid refueling, so in the depot, your refueling is in a matter of minutes, as opposed to a battery electric bus, which would be in a matter of hours. Really, that means we can have a one-to-one replacement of a diesel bus. Now, these are the kind of benefits that are often spoken about. There are lots of sort of softer benefits that in a depot you don't realise. Because we can use the same process as a diesel bus in the depot, the depot doesn't have to change what they're doing too much to change to the zero emission option. If you go to a battery electric bus, you've got to make sure everything is plugged in. You've got to change the way the buses come in at night. You've got to have a first in, first out system in the depot. So a lot has to change within the depot. Another thing that's often said about battery electric buses, to get the range up, there's opportunity charging. Well, as an engineering kind of solution, this works quite well. But as a practical solution, it does become difficult, because who pays for your charging infrastructure in the town? how do you charge for that infrastructure? If there's more than one bus route using the same infrastructure, what happens if your bus gets to that point and there's already a bus on there charging up and you have to wait? If a bus is late, one bus late in the early morning, it could throw your schedules out for the whole day. So there's a lot of sort of hidden issues with opportunity charging and some of the battery electric options that aren't always visible in the first place. So just a slide on sort of some examples of buses that have been powered by Ballard or are being powered by Ballard fuel cells. And probably for the UK audience mainly, you would see the double-decker bus. So there are double-decker buses, fuel cell double-decker buses coming online at the moment in Aberdeen and in London in the UK, which is a big advance, one-to-one replacement of diesel vehicles in the UK. Obviously, the UK is very heavily centred in the bus market on double decks. Now, coming on to cost, and the capital cost of buses fuel cell buses has been dropping dramatically. And as you can see, a number of projects there, all ones that Ballard have taken part in, you can see the cost of the bus dropping dramatically, right down to the last one, which is the H2 bus project that we're involved in, which is getting the price right down to commercial levels. Fuel cell buses are becoming a commercial proposition now. And there's been a couple of reports on the TCO. So we just looked at the capital cost, but the TCO generally is probably more important when you're wanting to run buses. And the statement here from a Deloitte Ballard report from 2020 gives a quote that really can become quite surprising, that not only could fuel cell buses the TCO could become less than battery electric buses, but actually will become less than internal combustion engine buses, which is extremely exciting and interesting. But just another slide on the TCO, again taken from the Deloitte report. There's a break-even point with battery electric buses in about 2024, 2025. And if you look at the graph on the right with the TCO of the buses, you can see that the longer range of the buses, the more it's beneficial for the TCO model of fuel cell electric buses. I mean, it is fair to say that there could be some routes where battery electric buses are suited to that, and so for the greater good, then why not? But there are an awful lot of bus routes that need to go to zero emission that you will need a hydrogen fuel cell bus. The competitive of fuel cell buses is here today. And quite often when we're in conversations about fuel cell buses, I hear a lot of old information, but there's been big improvements in the last 10 years. I've been working with fuel cell buses since 2009, and the change has been incredible. And with scale up and innovation, we'll see reductions in costs reducing by quite substantial amounts in the next few years. So now if we just move on to trucks, and trucks really are not as advanced as fuel cell buses in their actually being on the road, but fuel cell trucks are being spoken about an awful lot now, and I don't think it'll be very long before there's a number of trucks on the road. Now, the argument for using fuel cell trucks is very similar to fuel cell buses. So if we look at this slide, it's a slightly different slide, but we're basically talking about the same thing. So you've got power to maintain speed on demanding routes. We've got range and route flexibility. because we've got a higher range, you can be more flexible on your route that you take. You're not going from charging point to charging point. You've got a high energy density, so you can maximize the payload. And then the rapid refueling, which obviously for a truck, you want a truck on the road for as long as possible. And so rapid refueling would lead to high truck utilization. And I think this slide is a very nice slide. The sort of graphical presentation on the right is the fueling time for a diesel bus would be around 5 minutes. It has the longest range. It's what we're used to. A fuel cell bus, you'd have a slightly slower refueling time, but again, we're in the matter of minutes, not. And the amount of payload that you're losing because of using the hydrogen is minimal, but we've still got a long range on the vehicle. With the battery electric truck, we've got a very long recharging time at the moment between about 3 to 5 hours. But also what's very important is we lose a lot of payload in there and we lose a lot of range, which means that the truck won't be on the road doing its job for as long as you want. Another thing that I just wanted to briefly mention about fuel cells, and again when comparing to battery electric, is the sort of the full sustainability circle from production right through. So you can see from the graphic on the left that the amount of CO2 created, greenhouse gases for a fuel cell hybrid system is an awful lot less than to produce a battery electric system with the production of the batteries, etc. So that's very important. But another important thing is that there's already we can refurbish and reuse and recycle the hydrogen fuel cell, where with the battery electric there are still sort of problems. In theory we can recycle, in practice it's not really happening. So that's a very important point, the whole sustainability area. So finally, kind of moving on to safety and maintenance. So obviously safety is something that everyone involved in, well, any industry, but in vehicles is particularly concerned about. There are two main areas that we need to think about in safety. That's the safety of the vehicle on the road and the safety of the vehicle, or the safety of the personnel in the vehicle when maintenance has been undertaken and in the depot. And both are extremely important, but probably the area where there's more likely to be a problem is when you're undertaking maintenance, because obviously we could be going into systems and that where things could go wrong. But we have to look at regulation codes and standards, and then when you're coming into new technologies, sometimes these regulation codes and standards are running behind the development that's happening. Codes and standards can be up to 3 years behind development that's taking place. So we must pay attention to local laws and regulations. That goes without saying. We've got to have the correctly rated electrical installation within a workshop, etc. Correctly rated and fully calibrated equipment. That's very important to keep that up to date. And then if we're working on fuel cell vehicles in the hydrogen, we've got to think about our correct zone areas and safety in that sense to keep people safe. So maintenance workshops, we need to create a safe working environment. And there's three main areas that we need to think about when compared with diesel, three areas of concern. Is the hydrogen itself the properties are well understood with hydrogen. We know how it's going to react. High pressure, because the hydrogen used on heavy duty vehicles is normally stored as 350 bar gaseous hydrogen, so it's compressed hydrogen. But we need to make sure that we understand the pressure that's in there, and so we need to understand the high pressure. And then there's high voltage, but we have to remember that high voltage is also on battery electric vehicles and diesel hybrid vehicles, so that element is something that we need to mitigate all types of low and zero emission vehicles. But it's very easy to focus on the hydrogen, but don't forget about these other areas that are introduced that are different to diesel buses. So when we're talking about safety in the depot and maintenance, what we want to do is keep the messages simple. I really like the fire triangle as a message. It's very simple to understand. If you're going to have a problem with a fire or explosion or anything, we need to have oxygen. We can't get rid of oxygen, that's in the air all the time. We need to have fuel. In our case, we're talking about hydrogen, and we need to have a heat source or some sort of ignition source. But what we can do in a workshop, and we can make all our mitigation around this as far as the hydrogen's concerned, we can remove the fuel. So as long as we don't expose the technicians or anybody to hydrogen, so we keep that sealed, and as long as we remove any heat sources that could ignite, we've got two areas of that fire triangle missing, and we don't have a problem. And even if one of the areas goes wrong, such as there is a small hydrogen leak, then we still don't have an ignition source, so we're still not putting any hazard in place. What we also need to think of is working at height, because as you saw on the single deck bus, the tanks are on the roof of the bus. Working on the roof of the bus is not something we would normally do in a diesel workshop, so we need to take mitigation against that. You can have personal alarms for hydrogen. We can have alarms in the workshop, hydrogen alarms in the workshop, but a simple personal alarm gives an extra added layer of insurance. Special tools, we can have some spark resistant tools, and then personal protective equipment. In any sort of heavy duty workshop, we'd be used to dealing with PPE, but just make sure that PPE is appropriate to the hazards that we've got. I just wanted to mention risk assessment, because risk assessment is something that's spoken about a lot. Extremely valuable tool, should be used all the time in a workshop anyway. Within a hydrogen workshop, it's extremely valuable. But the things I would say about the risk assessment is make sure you use the correct people with the correct knowledge. That's vital when you're putting together a risk assessment. If you're having to make mitigations that are over complex or difficult to do, then you need to go back and look at the process, because that's when shortcuts are taken, when things are overcomplicated. If things are overcomplicated or you have to do so much just to do one thing, people will take shortcuts. That's human nature. And so you need to look at it and make your risk assessment as a very appropriate, but as easy as possible. And if you think everything's mitigations are getting too complex, maybe you need to go back and look at the processes that you're doing as well. And then just finally, I'm going to just wanted to mention some other things that we need to make sure that we do. And the first one is training. It sounds obvious, because obviously you need to train your technicians that are working on the vehicles, but you also need to make sure you're training your supervisors. They will be looking after the technicians that are there, so they need to understand what's going on, and your management. But it's also very important that you train any auxiliary staff so they understand what's happening in the workshop, what's going on, what they can touch, what they can't touch, etc. And you may even need to extend your training further out, because sometimes it might be that you need to actually train the public as well in some level. You're going to need to train your drivers. You might want to train your drivers with a little bit of knowledge about what's happening that's propelling the bus, the way things go. So you need to think about training, and I believe you can never give too much training. Need to look at your work practice, your method statements, your processes, look at risk assessments, as we've just spoken about, and all that. And also make sure that everything is documented. If it's documented, we can make sure things are happening right and have a good record of what's going on, and then we can move forward on that. But don't be afraid to change your process, to update your process, to update your risk assessment. You always need to move on, and so it's not a problem to keep reviewing all these things. So now I was going to pass on to Christina to continue and to talk about the marine environment for fuel cells. So thank you very much.